Good afternoon, everybody. In physics, today we will learn about fluid motion and viscosity. Our objectives are: what are fluids? How do the fluids move, means fluids in motion? Then, what is streamline motion, turbulent motion, laminar flow, and so on? What do we mean by Reynolds number, equation of continuity? Then we will study about Bernoulli's theorem, some applications of this, viscosity and coefficient of viscosity, Stokes law, and what we mean by terminal velocity, and finally, how does temperature affect viscosity. If time permits, we will study about some applications of viscosity in hydraulic systems. First of all, what we mean by fluids. Fluid is a term that refers to gases as well as liquids. Why so? Because gases and liquids have more in common with each other than they do have with the solids. In gases and liquids, having atoms or molecules, these are free to move around, whereas this is not so in the solid. In case of solid, they are locked, but in gases and liquids, they are not locked. The hotter the fluid, fluid means gases or liquids, the faster its molecules move on an average, and more the space the fluid will occupy. Moreover, unlike solids, fluids can flow. So, fluids refers to gases and liquids. Solids cannot be referred as fluids. Fluids can move or flow in many ways, like for example, water. Water can flow smoothly and slowly in a quiet stream or violently over a waterfall. The air may form a gentle breeze or a tornado. To deal with such diversified parts, it helps to identify some of the basic types of fluid flow. Now, fluid flow, you can call it as steady or unsteady flow. If the velocity of the fluid particles at any point is constant with respect to time, we call it as steady flow. Whereas, if the velocity at a point changes with the passage of time, we refer it as unsteady flow. We can also divide flow of fluids as compressible or incompressible. Most liquids, they are nearly incompressible. You cannot compress a liquid, or if so, only up to some extent. This means density of a liquid remains almost constant as the pressure changes. You keep on increasing the pressure on a liquid, its density will differ to a very small amount. To a good approximation, then, liquids flow in an incompressible manner, means they cannot be compressed, whereas gases, they are highly compressible. There are situations in which density of a flowing gas remains constant enough that the flow can be considered incompressible, means in general the gases, they are highly compressible. If you increase the pressure, the gas gets compressed, means occupies less volume, but we can take the gas to be as incompressible, whereas these are some of the situations only. Then you can also divide the fluid flow as viscous or non-viscous fluid flow. Then what is a viscous fluid? If you see honey, you pour honey from a tumbler, it does not flow readily. Whereas, if you make water to flow from a tumbler, it flows easily. ਗਲਾਸ ਦੇ ਵਿੱਚ ਹਨੀ ਲਓ, ਸ਼ਹਿਦ ਲਓ, ਸ਼ਹਿਦ ਈਜ਼ੀਲੀ ਫਲੋ ਨਹੀਂ ਕਰਦਾ। ਗਲਾਸ ਦੇ ਵਿੱਚੋਂ ਪਾਣੀ ਈਜ਼ੀਲੀ ਫਲੋ ਕਰ ਜਾਂਦਾ ਹੈ। ਸੋ ਇਸੇ ਚੀਜ਼ ਨੂੰ ਅਸੀਂ ਵਿਸਕੋਸਿਟੀ ਕਹਿੰਦੇ, ਵਿਸਕਸ ਕਹਿੰਦੇ ਹਾਂ ਕਿ fluid viscous ਹੈ, means honey is viscous. So, a viscous fluid like honey does not flow readily and is said to have a large viscosity. In contrast, water is less viscous and flows more readily. Water has a smaller viscosity than honey. The flow of a viscous liquid is an energy dissipating process. A fluid with zero viscosity flows in an unhindered manner with no dissipation of energy. Although no real fluid has zero viscosity at normal temperatures, but you can consider them to be having zero viscosity as they have negligibly small viscosity. Then we define an ideal fluid. It is that fluid which is incompressible and non-viscous. So, an incompressible non-viscous fluid is called an ideal fluid. What is streamline flow? It is that flow of a fluid in which each element of the liquid passing through a point travels along the same path and with the same velocity as its preceding element passing through the same point. Preceding means जो element, जो atom ਜਾਂ molecule ਉਸ ਤੋਂ ਪਹਿਲਾਂ pass ਕਰਕੇ ਗਿਆ ਹੈ ਉਸੇ point ਨੂੰ. A streamline may be defined as the path straight or curved, the tangent to which at any point gives the direction of the flow of the liquid at that point. If you see here, here you have velocity v1, at this point you have velocity v2, at this point you have velocity v3. A particle passes from this point, it has velocity v1. Any particle that is coming after this, if it passes this point with the same velocity, that is v1, and this point with velocity v2 and this point with velocity v3, means if each particle passing through these points passes with the same velocity, we call the flow to be a streamline flow. This means the flow is steady. That is also what we call a streamline. So, when the flow is steady, streamlines are often used to represent trajectories of the fluid particle. If you want to find out the direction here, what you will do? At this point, you mark a tangent. So, a streamline is a line drawn in the fluid such that a tangent to the streamline at any point is parallel to the fluid velocity at that point. So, steady flow is called streamline flow. Here you see, if you pour some liquid here, you will find the liquid coming out from these pipes. This is the steady flow of a liquid. Here you can put a colored liquid. Here we have a smoke streamer reveals a streamline pattern for the air flowing around this cycle. Then what is laminar flow? A liquid that flows slowly and steadily behaves as if it consists of a number of laminae, means streamlines or layers, one above the other. In case of a non-viscous liquid, velocity of all the particles at any section of a tube is the same. Turbulent flow. A liquid possesses streamline motion. Streamline means steady motion only up to a certain velocity. Means if its velocity is lesser than some limiting velocity, the flow of the liquid is streamline. This velocity below which the liquid possesses streamline motion is called critical velocity. And as soon as the velocity of the liquid surpasses this critical velocity, means becomes greater than the critical velocity, the elements of the liquid start moving in a zigzag path and the motion becomes unsteady. So, such an unsteady motion of the elements of the liquid along zigzag paths is called turbulent flow. Now, here you can see this is a turbulent flow, an extreme kind of unsteady flow that occurs when there are sharp obstacles. कोई waterfall है या if there is an obstacle है, bend है, तो उथे जो liquid ਦਾ flow है ਉਹ इस टाइप ਦਾ हो जाएगा, इसनों unsteady flow है, zigzag flow है, not any steady motion is there. Such a flow is called turbulent flow. What is happening is that velocity at any point is changing erratically at every moment, both in magnitude as well as direction. Again here you see in the picture a waterfall. Water at the top of the fall passes through a narrow slit here and the velocity increases at this point. So, this is again a turbulent motion. Here you can see these are the streamlines. These layers that are formed, they form a laminar flow. If you want to find out the direction of the streamline at any point, that will give you the velocity of the particle, you draw a tangent there. The tangent to the streamline gives us the velocity of the particle. This is a turbulent flow, a very clear picture you can see. There are so many swirls, eddies and vortices. Again this is a turbulent flow in the picture. Laminar flow, you see when the liquid passes any point in layers, that is called laminar flow. And if this changes, path changes, velocity changes, increases or decreases suddenly at an obstacle, this is an obstacle shown here, then the flow becomes turbulent. What is Reynolds number? Any kind of flow description such as Poisson's law, which gives us the rate of flow of a liquid, they are valid only for conditions of laminar flow. At certain velocity, which we have defined as critical velocity, the flow becomes turbulent with the formation of eddies and chaotic motion, which do not contribute to the volume flow rate. This turbulence increases the resistance dramatically, so that large increases in pressure will be required to further increase the volume flow rate. Experimental studies have characterized critical velocity for a long straight tube in the form of critical velocity equal to n eta upon rho d, where d stands for diameter of the tube, eta is the coefficient of viscosity of the liquid, rho is the density and n is what is called Reynolds number. If this Reynolds number, these are the experimental studies that have been done. If Reynolds number is in between 0 and 2000, the flow is said to be laminar, that is streamline. If n is greater than 3000, it is ought to be turbulent. If n lies between 2000 and 3000, the flow is referred as unsteady. There are certain assumptions for the fluid flow. All fluids move with streamline flow. So, जितने भी experimental works, जितने भी descriptions हैं, they are for streamline flow. Secondly, we consider that the fluids, they are incompressible and there is no internal friction. Rate of flow is the volume of a fluid that passes a certain cross sectional area per unit time. The volume fluid is given by product of area A multiplied by V t. V t is the distance. If you see, if you consider an area here, in certain time t, it will move through this distance. Then what is this distance? It is calculated as V into t. V is equal to d over t, d equal to V into t, and this gives you the volume. Then what is rate of flow? It is volume passing per unit time. So, divided with time, you get V. Here V is velocity, velocity into area. So, rate of flow is velocity into area. So, for an incompressible frictionless fluid, velocity increases when cross sectional area decreases. This is what is called equation of continuity then V into A. If you decrease the velocity, if you decrease the area, the velocity will increase. If area is larger, velocity is smaller. Area becomes smaller, velocity increases. Equation of continuity states that for an incompressible fluid flowing in a tube of varying cross section, the mass flow rate is same everywhere in the tube, means mass of the liquid flowing through any section is same, because there is no accumulation of the liquid anywhere. किते accumulate नहीं करता liquid, जिन्ना mass एक side तो enter कर रहा है उन्ना ही दूसरी side तो बाहर जा रहा है tube दे. Mass flow rate is simply the rate at which mass flows past a given point. So, it is the total mass flowing past divided by the time interval. So, equation of continuity is reduced to A1 mass, what is mass? Density into volume. So, A1 V1 into rho 1. Flowing per unit time, V velocity, velocity per unit. Generally, density stays constant and then it is simply the flow rate area into velocity. So, mass flow rate has the same value at every point along a tube that has a single entry and exit point for the fluid flow. Now, here you see a person is holding a pipe. Here the area is larger, so the velocity is smaller. Here he is reducing the area. He has kept his thumb in front of the tube, the velocity has increased. So, if area is reduced, fluid must speed up. If the fluid is incompressible, density remains constant throughout, then A1 V1 is equal to A2 V2. Then what does AV represent? It represents the volume of fluid per second that passes through the tube and is called volume flow rate. If you see in your picture at position 1, you see smaller area, larger velocity shown with a large arrow, larger area, smaller velocity shown with a small arrow. Then Bernoulli's principle. Who is Bernoulli? He was a Swiss scientist. He was born in 1700s and he is famous for his work in fluid pressure. A liquid possesses three kinds of energies: pressure energy, potential energy and kinetic energy. What is pressure energy? The energy possessed by a liquid by virtue of its pressure. If H is the height of the liquid column, then pressure is H rho g, you know. Rho stands for density of the liquid, g is acceleration due to gravity, H is the height of the liquid column. Then what is pressure energy per unit mass? Divide pressure by density, you get H into rho, it is called pressure energy per unit mass. What is pressure energy per unit volume? Divide by rho g, you get H, that is pressure energy per unit volume. Potential energy, the energy possessed by a liquid by virtue of its position or height. You know potential energy is mgh, then potential energy per unit mass divided by m. Kinetic energy is the energy of a liquid by virtue of its motion. When the liquid is in motion, it has kinetic energy. Then what is kinetic energy per unit mass? You divide kinetic energy with mass, that is called kinetic energy per unit mass. Then Bernoulli's principle states that total energy, total means sum of pressure energy, potential energy and kinetic energy of an incompressible, means the liquid or fluid which is not compressed, and non-viscous fluid having zero viscosity, ideal, which you call as ideal fluid, when you say incompressible and non-viscous fluid, means we are talking about ideal fluid. In a steady flow through a pipe remains constant throughout the flow, provided there is no source or sink of the fluid along the length of the pipe. So, total energy of an incompressible and non-viscous fluid in steady flow remains constant, and what should not be there? There should be no source or sink of the fluid. Now, during the statement there were certain assumptions that were made. Most important is that there is no loss of energy due to friction, means we are talking about in ideal conditions, frictionless conditions. Some of the other assumptions: 1, liquid is incompressible. When I say liquid here, means we are referring to fluids. Fluid means both liquids and gases. Secondly, the fluid is non-viscous, means liquid or gases that you have taken, they are non-viscous. The flow is steady and the velocity of the liquid is less than the critical velocity for the liquid. So, sum of pressure energy, kinetic energy and potential energy is always constant. Then you can also say sum of potential energy per unit volume. This is here what we are doing is we are referring to pressure energy per unit volume, kinetic energy per unit volume, potential energy per unit volume is constant. This is the derivation of Bernoulli's equation. You consider a certain volume delta V of mass delta M of incompressible fluid. The fluid is passing through this pipe not having uniform cross section. Cross section at this point is smaller as compared to the cross section of point 2. Cross sectional area of point 2 is much larger as compared to the cross sectional area of point 1. When the liquid enters here, velocity of the liquid is V1. So, its kinetic energy is half mv1 square. The liquid passes out from here. So, its kinetic energy is half mv2 square, difference is half mv2 square minus half mv1 square. Similarly, this is at a height y1, this is at a height y2. So, change in potential energy is mg y2 minus mg y1. Now, what is the work done by pressure? You see, it is force into displacement. Let us say the liquid of mass delta m is displaced through delta x1 distance here and delta x2 distance here. So, work done here is force into displacement, here it is force F2 into displacement delta x2. What is force? What is pressure then? First let us define pressure. It is force per unit area. Then what is force? Force is pressure into area. So, the force with which the liquid is pushed here is equal to pressure at point 1 multiplied by area of point 1 into delta x1 minus p to a to x1. This work done by the pressure is equal to sum total of kinetic energy and potential energy. And then you reshuffle the terms, you get P1 plus rho g h1 plus half rho v1 square equal to P2 plus rho g h2 plus half rho v2 square. So, the three variables that are given by potential energy, kinetic energy and pressure energy are: potential energy gives you the variable. What is the term that changes in the case of potential energy? When you say it is mgh or rho gh, it is h. In case of kinetic energy, you see it is half mv square, mass remains constant. What changes here is speed. Speed is variable. In the case of pressure energy, what is variable? Pressure is variable. So, according to Bernoulli's principle, the three variables height, speed and pressure, they are related by energy conservation. If one of the variables increases along a streamline, then at least one of the other two must decrease. अगर height बढ़ जाएगी तो speed या pressure कम हो जाएगा. अगर speed बढ़ेगी तो height या pressure कम होएगा. Pressure बढ़ेगा the height just speed कम हो जाएगी, decrease हो जाएगी. So if speed goes up, pressure goes down if you are taking a horizontal pipe. This is the case which I am referring to, the horizontal pipe. You have P1 plus rho g H1 plus half rho V1 square equal to P2 plus rho g H2 plus half rho V2 square. Height is same. We take the center line, H1 and H2 are same, H1 is equal to H2. So, the term containing height goes off, you get P1 minus P2 equal to half rho V2 square minus half rho V1 square. If the fluids are at rest, this means velocities they are 0, V1 and V2 are 0. Fluid is at rest, it will go height and pressure. Then P1 plus rho g H1 is equal to P2 plus rho g H2. So, P1 minus P2 is equal to rho g H2 minus rho g H1. And this is the relation that we use for finding pressure P at a given depth H equal to H2 minus H1 in a fluid. Some of the application, most important application is that of an airfoil. Why do we have the wings of a plane in the shape of airfoil? Because when a plane is moving, the pressure on the top surface of the wings is lower than the pressure beneath the wings. Why? Because the air has to cover a larger distance on the top as compared to the air flowing below the airfoil shape of the wing of the aeroplane. So, if the air is to cover a larger distance, it will have to flow with the larger velocity on the top. ऊपर velocity ਵੱਧ ਹੁੰਦੀ ਹੈ, नीचे velocity ਘੱਟ ਹੁੰਦੀ ਹੈ. ਜੇ ਉੱਪਰ velocity ज़्यादा है तो ऊपर pressure घटेगा. ਅਸੀਂ देखा constant रहना है. Pressure energy, kinetic energy और potential energy per unit volume ਦਾ ਜਿਹੜਾ ਜੋੜ ਹੈ ਉਹ constant ਰਹੇਗਾ. Height ਤਾਂ ਸਾਰਿਆਂ ਦੀ same ਹੈ, wing ਦੇ ਵਿੱਚ height does not differ. So, if velocity has differed, pressure is ought to differ. Height is same, velocity of the on the top is more, so pressure is lesser. Velocity below is lesser, pressure is more. So, a pressure difference is created and the lift force that supports the plane in the air and the difference of pressure creates the aeroplane to move upwards. This principle allows birds and planes to fly. Similarly, birds have the same characteristic, velocity on the top lesser, velocity more, velocity below lesser, and there is the pressure difference. So, the secret behind flight is under the wings. Air on the top of the wings has to travel longer distance, air below has to travel smaller distance. So, this is a very good diagram here. On the topmost, it has shown a larger area. This means velocity is more here, velocity is lesser here. Wherever velocity is lesser, pressure will be more, and air on the top of the wing is travelling faster. So, air pressure is less. The engine provides you the thrust, the wings provide you the lift, gravity provides the g force, and fluid friction provides the drag which makes the flight of an aeroplane. This is the shape of the wing that is shown. On the top, faster air, lower pressure, below slower air, faster higher pressure. So, there is a lift force. As the air moves fast over the top of the wing and slower below the wing, it leads to lower pressure over the wing and uplift to raise the plane. Similarly, curved path of a ball's path will curve due to its spin, which results in the air speeds on the two sides of the ball not to be equal. Now, if you see in this side, the direction of the air outside is same as the direction of the ball, and on this side this was going anti-clockwise, this is clockwise. So, the speed is lesser. On one side the speed is more, on the other side the speed is lesser. So, there is a pressure difference.